Okay, geometry fans, welcome to our lesson for today. And the topic, it is called trigonometric ratios. All right, and trigonometry, the definition of trigonometry is actually triangle measure. Triangle measure. So trigonometry is kind of an intimidating word, but when you hear it, literally the meaning is triangle measure. And what we're going to do today is we're going to measure triangles, basically. Before we start, though, let me tell you your joke of the day. It's not a math joke, but I hope you'll appreciate it anyway. And the question is, what did the baby corn say to the mama corn? And the answer is, where's popcorn? Okay, so here we go. I'm going to teach you a word today. It's not a real word, but in geometry we like to think of it as a word. It's called SOHCAHTOA. SOHCAHTOA. It's very important that you know how to spell this. And the nice thing about it is that it's spelled the way it sounds. SOHCAHTOA. Oa. Alright, now you're thinking, well, what the heck does this mean? Well, I'm going to tell you. Up until this point, when you look at a triangle, for example, ABC, we can talk about the sides. In this case, 3, 4, and 5. Now we can talk about angles as well, but we don't have any equation that compares the sides and the angles. We would say all the angles of a triangle, all the interior angles, always add up to 180 degrees. And we would say that the sides add up to perimeter. But up until this point, we've never put all of this into the same equation. Well, there's a way that you can compare angle measure to side length. And I don't mean just saying which side is longer, which angle is shorter. Okay, we've done that, right? The biggest angle's opposite the longest side. You could say that opposite the 90, 5 has got to be the longest side. You could say that 4 is the middle side length. So angle A would have to be the middle angle. Angle B would have to be the smaller angle. Okay, so we can compare like that, but we can't use an equation. But there's a relationship, and this only is true in right triangles where we can put sides and angles into the same equation. And what we do is we compare an angle measure to side length. We compare an angle measure to side length. And we have 3 ways that we can compare this. We have something called the sine. And the sine of some angle, okay, there's the angle symbol, equals, it's the ratio of the opposite side to the hypotenuse. Okay, and I'll explain what opposite, all that stuff means in a second. Let's just write these down. So the sine of an angle compares the opposite to the hypotenuse. The cosine of an angle compares the adjacent side to the hypotenuse. And the third one is called a tangent. The tangent of an angle is the opposite side divided by the adjacent side. Okay, so what does this mean here? Well, the key to this, it always has to be a right triangle that this works for. Let's say we choose angle A. Okay, so we're going to use this angle at the top. Now, you have 3 sides of the triangle. In comparison to angle A, the 4 is the opposite side. I'm going to label that op, okay, OPP. Now, the 5 is opposite 90. Well, that's always called the hypotenuse, HYP. So the third side here, this other leg, which is 3, now that's not opposite angle A, it's next to it. So we call that adjacent. All right, remember, we've used the word adjacent to talk about things that are next to each other. And that's what's happening in this situation. So These are all called trigonometric ratios. These are trig ratios. What you're comparing is an angle measure to two sides of the triangle. The reason why we have three of these, sine, cosine, tangent, is because when you look at the sides of the triangle, you could compare these three ways. You could compare the 4 and the 5. You could compare the 3 and the 5. You could compare the 4 and the 3. Okay, so we're going to write down here on the side, when you abbreviate this, and let me show you on your calculator here, when you look at this, notice it, you've probably seen before, sin, cos, tan. You've seen these buttons. Well, those stand for sine, cosine, and tangent, and we're going to be using those in a couple of minutes. Alright, so let's look at this here. The sine of angle A, it's always the sine, the cosine, the tangent of an angle measure. Okay, so the sine of angle A equals, it's the opposite length divided by the hypotenuse. So in this case, here's angle A, the opposite is 4, and the hypotenuse is 5. So the sine of angle A is 4 divided by 5. The cosine of angle A, cosine of A, cosine is adjacent divided by hypotenuse. So the cosine of angle A is the adjacent side is 3 and the hypotenuse is 5. The tangent of angle A, which we abbreviate tan, okay, so we have sin is sine, cos is cosine, tangent of angle A. The tangent is the opposite over the adjacent. So the opposite is 4 and the adjacent is 3. When I solve these problems, I like to label the sides adjacent, opposite, hypotenuse, because then I just have to match them up to the ratios. I just match them up. When you write this, it's always the sine of an angle, the cosine of an angle, the tangent of an angle equals a fraction, and the fraction is the ratio of your sides when you do this. Now, the other thing that we can do here, what if you had chosen a different angle? What if we had decided to look at angle B here? Well, which side would be opposite for angle B? The opposite would actually be the 3. The adjacent would be the 4, and then the hypotenuse would still be the same. The hypotenuse would still be the 5. So we could also, over here on the side, we could have done the sine of angle B. And the sine of B is the opposite, which would be 3, over the hypotenuse, which is 5. So the sine of B is 3 over 5. The cosine of angle B, cos B, would be the adjacent, which is now 4, divided by the hypotenuse, 5. So it's this fraction 4/5. The tangent of angle B equals the opposite, which is 3, divided by the adjacent, which is 4. Okay, so it depends on which angle you choose. That's very important. We never choose angle C. You don't choose the right angle. SOHCAHTOA is going to fall apart if you try to do the right angle. Okay, now let's go back to this word SOHCAHTOA. So what does that actually mean? Well, S is for the sine, and then O over H, sine equals opposite over hypotenuse. So CAH, C-A-H, cosine equals adjacent over hypotenuse. This is how you can remember it. It's a quick way to remember. SOHCAHTOA, tangent is opposite over adjacent. Tan is opposite over adjacent. SOHCAHTOA. That's how you remember it. Okay, so let's do a couple of examples here. Example number 1. Find the sine, cosine, and tangent for angle D. Alright, we're going to use angle D. So I'm going to circle that. because that's going to determine which sides are opposite, adjacent, and hypotenuse. The opposite is 12. If I draw an arrow from angle D, opposite is 12. The adjacent is 5. Now the hypotenuse, we don't know that yet. We need to find that. Well, how can you find it? They give you the legs 5 and 12. Let's use a squared plus b squared equals c squared. Let's do the Pythagorean theorem. Okay, so we get the legs are 5 and 12. So we get, that's 25, plus 12 squared is 144, equals c squared. That adds up to 169. Now to solve that, we need to take the square root of both sides, and we get 13 is equal to c. So we can go back to the picture now. The hypotenuse is 13. Directions say find the sine, cosine, and tangent for angle D. Alright, so here we go. Sine angle D. So, now I'll go back up here to SOHCAHTOA. So, sine is the opposite divided by the hypotenuse. So the sine of angle D, opposite is 12, over the hypotenuse 13. Cosine, so ka. Cosine A is adjacent over hypotenuse. Cosine of D is 5 over 13. And then the tangent of angle D, tangent is opposite over adjacent, toa. Opposite is 12, adjacent is 5. And those are the answers. Alright, so we're going to stop for a minute here, and then we'll take a look at the rest of this side.